Okay, rewind. There is a general understanding, okay, now we have the slides, that spoken languages emerged more than 100,000 of years ago, according to Wikipedia. Even though the first writings were invented around 3000 BC, formal education was only introduced much later during the Middle Ages. And this was limited to the upper class, to churches and monasteries. So you can imagine that a really small percentage of population, of the world population, could read and write. Mass public education was only introduced much later during the 17th century. So you can imagine that all this time, most of the communication between human beings took place in spoken form. Now, every retelling of the same story distorted part of the details little by little. It's not surprising that today it's difficult to distinguish between myth and fact. Even words themselves and their meaning changed over time. Today we know that thanks to etymology, which studies and documents the origin of words. Now, somebody had to backtrace all this evolution, starting from the current form of words back to the old days and research everything and eventually document them so we can all benefit from their knowledge. Today, we live in a world with real-time worldwide video communication tools, collaborative drawing tools, virtual reality, LLMs capable of speaking out loud text, creating poems and generating videos. In contrast, software teams often rely on ancient communication methods to transmit information from one member to another, which is spoken form. Now, as an existing team member or a new team member, the ongoing process, or the onboarding process, becomes a real adventure. You have to find the right person who knows how to do stuff in the company or to do a certain process. Different team members know different information because it's changed over time. So some information was distorted or even lost because team members often depart, taking with them part of that knowledge. So we need to rediscover it again and again. We involuntarily become code etymologists, doomed to search for lost information. Hello, everyone. My name is Andrei Pfeiffer, and for the past years, I've been a code etymologist. And today, I would like to share with you what we can do to prevent our current and future team members to also become code etymologists. Now, when was the last time that you said it yourself or heard somebody else say, there is no documentation? I started saying this and hearing this myself once I began working on large projects that span over multiple years and having multiple team members, which is the topic of this day at JSHeroes. Now, why do you think there is no documentation? Well, the obvious answer is that nobody wrote it, but I have a theory. I don't know if it's the only reason, but it could be because of agile development. Why is that? Well, because the Agile Manifesto for Agile Software Development has 12 principles, and the sixth principle says that the most efficient and effective method of conveying information to and within a software development team is face-to-face communication. So somewhat might misinterpret this as being the only way of communicating information. Because why should we use less efficient and less effective ways, like, I don't know, writing or other communication methods? But the Agile Manifesto doesn't mention anywhere that we shouldn't document our code or our processes at all. In fact, there is a somewhat hidden history page that clearly states that we embrace documentation, but not hundreds of pages of never maintained and rarely used tomes. And this perfectly describes the difference between comprehensive documentation, which agile development tells us to avoid, and the agile or pragmatic documentation that we should embrace. But what types of documentation or what parts of our process should we document? When we say there is no documentation, like, what are we actually referring to? Well, there are multiple things we might refer to. For instance, we might refer to how the project is set up for local development. What are the coding guidelines and standards used within our team? What are the development workflows, like the Git branching strategy, or the code review process, or the release cycle? What are the product requirements, the features, the high-level use cases, or the low-level test cases and acceptance criteria? What are the data structures and contracts and domain entities? Or we might refer to what is the library of reusable UI components used within our product? Or we could be interested in the reasons behind important technical decisions that were taken in the past. Now, as I only have 25 minutes left from my talk, I can only cover 2 of these topics, and we can discuss about the rest during the breaks. So, project setup. And in other words, how do we get the project running locally on our development machine? Now, fortunately enough, in the JavaScript ecosystem, part of the setup process is self-documented. Once we get the URL to the main repositories, consider that we are using a versioning system, we can clone it, probably using Git. We install the dependencies using your favorite package manager. And we should look into the package.json file at the script section and look for a script that looks something like start or dev. We run npm start or npm start dev, npm run dev in order to start the project. Now, this might be sufficient for small and personal projects, but for real-life products, we usually need a lot more of additional steps. I will only cover 2 of them. For instance, we might require to install certain prerequisites beforehand, or what environment variables are required in order to start the project for local development. So in Node-based projects, one prerequisite is Node.js. I guess you all have Node.js installed on your computers, probably, but let's consider that you are joining a new company, or you change your laptop, and you have to set up your project again. You look at the README file, you see, OK, I need to install Node.js. What version do you install? Well, the README file doesn't say at this point. So what do we do? Well, we ask one of our colleagues. We send a private message. Hey, what Node version do you use for this project? They might say, I'm using version 20, but I don't know about the others. So you ask the others. You send a group message on your internal communication tool. Hey, I'm curious, what Node version do you use for this project? And we might get different answers. 22, 18, 21. Get another message. I'm using the latest and greatest, because I'm always upgrading and keep up to date. We might get, at some point, a private message. Don't tell the others, but I don't use Node. I use Bun, because it's faster and newer. But at one point, you get a message from the infra team, infrastructure. So, hey, I see you're using Node, and we need to update our production servers because we're using an obsolete version. So what version should we update to? And you don't know, because we don't have settled on a specific version. So now it's time for the entire development team to sit down, debate, and decide on a specific version, and of course, document it so everybody can reference the same version. So we write it down in our README file, and of course, everybody will follow, will read this README file, and every time we update it due to a security patch, for instance, or to an upgrade, everybody on the team will update their version as well, right? That was rhetorical, of course, that's not what things happen in real life. So that's the thing with written documentation. It's great as a first step, but it often gets overlooked, and it can get obsolete if not actively maintained. So let's see how we can improve this. Well, we could move the definition from a plain text file, which is a README file, to code. We can define it in our package.json file under the engines section, and we can specify the Node version here. Now, this won't have any actual effect. It's just purely informational. But if we add a new file, .npmrc, which is a configuration file for Node.js, which includes the line engine-strict equals true, now, whenever we run npm install, the package manager will look at the version definition in the package.json file and compare it with our currently running local version of Node. In case there is a mismatch, we will get an error, letting us know which version should we actually use. So with very simple standard configuration, we have enforced that and ensure that all the team members will use the same version in local development, but also during production builds as well on any environment. Now, Nicolas will cover code refactorings later today, but take note that documentation should also be refactored. So instead of leaving the explicit version in the README file, we should reference it to the source of truth. Moving on to environment variables, the de facto way to define environment variables for a project that at least I know of is to have a file named .env and display there the list of variables in key value pairs. And then we load them in the application, in the Node.js application, using a package like .env, which will parse this file and basically load the variables in the application. Now, you might know that these files should not be committed to Git because they usually include sensitive information, API keys, client secrets, credential passwords, and so on. So how do you communicate all these variables which are required for the project to the entire team and the infrastructure team and your team members or development team members? Well, one popular solution would be to have another file, .env.sample, which gets committed to the central repository, which includes only the variables and any non-sensitive information. Every time you need to add a new key, you have to let everybody know, hey, I have updated this file, please add this variable to your local .env files, and then update all the configurations on all the environments where we deploy to in order to include this new variable. Now, with only a handful of variables, this is pretty manageable, but for instance, the project that I'm working on has more than 200 environment variables to configure our application. So it is really tedious, error-prone, and it's a nightmare to configure all, and we have multiple environments as well. So an alternative solution would be to move the definitions into code. Here I'm using a schema validator, Zod, if you are familiar with it, and basically define which keys are required, and we can mark any optional keys as well. Now, the benefit of this is that this code is executable. So we can use this schema to parse process.env when we load the application. Process.env is the global object in Node, which includes all the environment variables that are loaded in the application. If there is any variable missing, this will throw an error, the application will crash, and will give us an explicit message regarding which variables are missing. So we made sure that our application doesn't start without all the required variables in local development and also in any other production environment as well. So it's really, really beneficial. I highly recommend type-safe environment variables with Zod, an article written by Jacob Paris. I have only covered the basics here in my talk, but the article goes into much detail regarding compile time, type safety, and how to display a friendlier list of missing variables. So please do check it out. I will post my slides on the Slack channel afterwards, so you don't have to take pictures or take notes. So writing important information is a very good start because everybody can reference it, the source of truth. But moving the important information into code is so much better because code is readable, but it's also executable. And if we can execute it, then we can automate certain processes and ensure that everybody on the team uses the same workflow and the same practices. Now, when we say there is no documentation, we might refer to DTOs, like data transfer objects, or domain entities, or, I don't know, request payload, or response data, or function signatures, or whatever data structure, we might refer to that we don't know what does it include. So there is a never-ending debate between values and types, between dynamic and static analysis, between runtime and compile time, between unit tests and type checkers. In the end, values tell us the reality. They tell us how things actually are at the moment. In contrast to types, who show us the theory, how things should be or could be. Now, if you used types before, at least in the JavaScript ecosystem, you know that they only have value during development, right? They are completely stripped away at runtime, so they have no effect on our actual applications running in production by our users. So this is probably one reason that many development teams don't use types at all, because they don't bring, in the end, any value to the users. So let's take a piece of untyped code. I have a simple function, fetches a list of messages from an API. Since this code doesn't tell us, or doesn't tell me, what should I expect from this function to return, I have to execute it. And I execute it, and I get this response. So it's an array of one object, and it has some different fields, ID, content, OK. But three of them are raising some questions, like this status 2. Like, what does it mean? What does 2 mean? And are there any other values that it could have? I don't know. What about message type text? Are there any other types of messages besides text? Probably, but we don't know from this code. And annotation null. Like, why is it null? When can it be not null? And what shape could it contain? We don't know. And that's basically the limitation of values. They tell us how things are at the moment, but they don't show us the structure of the potential structure of that data. So we could convert this code into TypeScript. So we could say that this function will return a promise of array of messages. Great. And we have this message type, this message structure. ID number, content string, makes sense. But then we have status number. Could it be any number? I don't know. That's what the type definition says. What about message type string? Could it be any string? Probably not, but we don't know. We don't know exactly. This tells us even less information than before, actually. And annotation could be null or this data structure annotation. We don't particularly care about the structure of annotation, but we can see that it's a nullable field. But we don't know when it can become non-nullable. So it gives us a little more information in some regards, but still doesn't answer the initial questions. And that's the thing with JavaScript types, or types in JavaScript. TypeScript, for instance, is a gradual typing language. We can define types in multiple ways. Some type definitions are really broad, that don't help us that much. Others are really more narrow and more focused and do convey more information. And also, there are many flavors of TypeScript. There isn't a single type of TypeScript. Your TypeScript is different than my TypeScript because we might have different configurations in the tsconfig file, right? Stricter or looser. So let's see how we can improve this type definition to convey more meaning and more structure. So whenever we have a limited set of values, the de facto way to define them is to use an enum. Doesn't matter which technical approach you have to define enums. Here I'm using a TypeScript enum. So basically, I'm defining a map between the numeric value and some string, some meaningful string. And now I can clearly see and figure out what that number 2 represents. And I can use this enum in the type definition to let all the team members that, OK, this status can have one of these values. Moving on to message type, I know from the runtime value that one of the potential values is text. Searching through code and asking my teammates, I find out that, OK, there is another potential value, which is comment, and I document it here as well. Now, as a side note, the differences between literal unions of literals or enums, or choosing between strings and numbers is up for debate. If you're interested in these details, we can discuss about this during the breaks. There are also multiple ways to define enums, pros and cons for each choice. But for the sake of code etymology, the technicalities behind this are irrelevant, so it's not important. Now, the third and last field that I want to talk about is this annotation field. Now, as a rule of thumb, whenever, from my experience at least, whenever we have a data structure that includes one or multiple optional or nullable fields, there is a high chance that there are actually multiple data structures hiding inside a single one. An even more stronger hint is when that object or that data structure includes a field named type something, like we have message type, that has also a limited set of values. So in our case, which is usually the case probably in your code as well, whenever the message type is text, the annotation is null, and whenever the message type is comment, the annotation has this shape, this annotation shape, which again, we don't care. So instead of looking at the message type as having one optional or one nullable annotation field, we could break this into two separate objects, and which is called the discriminated union, and basically define them accordingly based on this message type and even name them appropriately. So we have a text message and we have a comment message. We can have either one of those. And our actual message type is a discriminated union between those two explicit types. Now, this is a very small and minor example from my experience and in real applications. These data structures are much larger, so more complex. We have different combinations of different fields, so you have to remember or ask anybody, hey, when this field has this value, like what combination should we expect from to have at the runtime? So this basically clearly documents the structures, the potential structures that it can contain. So here is the entire type definition, including the enum and the discriminated union. You might say, but Andrei, this is much larger than the one before. That one was much shorter. And yes, this is larger because it communicates more. You don't have to ask questions regarding what is the structure of this, what is the meaning of code. So this is why longer text and longer code sometimes is welcome. Now, we have a pretty good definition at compile time, but we still haven't fixed the runtime, because there is no guarantee that the structure will be respected at the runtime. So can we have both? Can we have the best of both worlds? Values and types. Well, this is one of the few situations where, yes, with minimal overhead, we can have the best of both worlds. And the answer is schemas. Again, schemas, as we saw in the previous chapter. So I won't cover the details. I don't have time to go into the details of what schemas are and how they are used. Sandrina, who will be coming right in the next talk, will go into much detail about JSON schemas, the standard, besides schema definitions and validation. But I just want to show you what it looks like, how to translate that type definition into a schema definition. So here is the previous type definition, and I'm just transitioning it to a schema definition. So what you see in color, in brown or yellow or whatever the color is the extra code that comes from the schema definition using Zod as a schema validation library in this example. And keep in mind that this is not TypeScript, this is JavaScript, this is runtime code, right? And just as you saw in the example in the previous chapter where we validated the environment variables at runtime, we can use this schema definition to validate any data structure at runtime, whether it's a request payload or an API response from a server or a form, which will be covered by Sandrina. We can use this single definition to validate code at runtime. And the best thing is that with a single extra line of code, we can infer the type from the schema definition. So we get compile time, safety, and type definitions as well. So as long as we have longer code that communicates meaningful information, it's fine. I mean, don't be afraid to add extra code in order to communicate more to your team members and to your future self as well. So there are so many other things that we can cover in regard to code etymology. If you're curious about those or you want to revisit the topics covered in today's talk, I highly recommend you check out the Code Etymologist blog series on my personal website, andreipfeiffer.dev/blog. And at the end, before we conclude, whoa, I'm really fast. Keep in mind that documentation is about, basically in a general sense, about communicating knowledge, nothing else. And we can communicate in different ways. We can talk and speak about it, which is essential before making decisions, having a debate. Okay, it's really important to be able to communicate by talking. But important decisions should be written somewhere in order for all the team members to be able to reference the same source of truth. And even more important decisions that are written, if they can be translated into code, that's so much better, because code is executable and it can be enforced and automated. So it prevents any accidental misusages. Now, if we don't get past the first step, if we don't get from speaking to writing, then somebody will eventually become a code etymologist, which will have to search for that information that wasn't written down in all different places. So in case you become a code etymologist yourself, keep in mind that this basically implies to read a lot of code, to talk to your team members, to ask questions, to understand decisions, and eventually to document them so your future self and other team members won't have to go through the same process again. Because we all blame the lack of documentation, but at the same time, we all appreciate good documentation. So we just have to make the collective effort to contribute to the creation of documentation. Thank you so much for being here. Thank you for listening. I'm looking forward to talking to you during the breaks. I'll be here for the remainder of the event. And yeah, see you around, and peace to all of us. Thank you.